So I'm going to pour 1/4 of a tablespoon of baking soda into a shot glass.
I am going to pour some vinegar into the shot glass.
Good.
Boom! I don't know why I said that, but boom.
Yeah,
Okay.
muscle.
That's it.
Whoa!
Wait. I only poured 1/4 of a teaspoon. All right, so now we're gonna get a bigger chemical reaction. Whoa. So 4 of these. I'm excited.
And I will be pouring some vinegar. Oh God, oh God, oh God! Whoa, Michael, look!
Do not try this at home. We are trained professionals. We're not trained, but we're professionals.
Nice.
Whee! Whoa! Pour more on top.
More!
More. We must have more.
Oh God! Oh God! Oh God! Oh
That was amazing.
Yeah.
Okay, so let's test to see if this is an acid or a base. Let's use cabbage juice.
Ooh, red.
It's an acid.
I am mixing the baking soda to dissolve the particles. So next I will be putting some of this concentrated cabbage juice like Michael did.
Yeah.
Since this is blue, it is a base.
So this is an acid, that's a base, and we're going to be pouring them together. So, all right.
Whoa!
It's purple now. Well,
Oh wow, that's like a dark purple.
I
It's
know.
like midnight.
I know.
Oh, that looks so cool.
That's a really good color. So this vinegar is an acid. If I pour more vinegar in here, is it going to be more of an acid?
Looks like we got our answer.
Can you pour more? Pour more. See if it's gonna
Sure.
be more.
Sure. I'll do that.
More blood. So let's see if we pour more baking soda, it will turn more basic. That. Oh!
More.
Yeah, it's more. We need more vinegar. Oh, more baking soda. Yeah, that's brilliant.
That's brilliant.
More baking soda. Oh, more.
I'm shaking this because why would you not shake it? Be more of a bit. Oh wait, it's now turning blue. It's a base now.
So we have some sodium and we have some carbonate. So the carbonate has a double bond between oxygen, a bond with oxygen, and another bond with oxygen. But then the oxygen has a bond with hydrogen. And then if you put water, the sodium becomes positive and the oxygen becomes negative. And the sodium will leave the oxygen and go somewhere else. And that's why. So then the oxygen can take a hydrogen ion, and that's why it's a base.
So today we're going to be looking at acetic acid. Here's it in chemical form. 2 carbons and 3 hydrogens. So what the second carbon has is a bond with oxygen, actually a double bond, and another bond with oxygen. But this has a bond with hydrogen. Yay! Alright, so I'll erase this bond. This is negative, this is positive. It's called a hydrogen ion. And now this is no longer connected. It can give these. That's what makes it
This is a
an
chemical reaction between vinegar, acetic acid, and baking soda, sodium bicarbonate. The reaction results in sodium acetate, carbon dioxide, which is a gas, and water. To find out how much baking soda and vinegar to mix, we will look at the periodic table of elements. The periodic table lists all the elements found in nature. We are interested in hydrogen, carbon, oxygen, and sodium. When we click on one element, like hydrogen, it shows the mass of that atom at the bottom. This way we can find the mass of carbon, which is 12, oxygen, which is 16, and sodium, that is 23. To find the weight of each molecule, we need to add together the weight of every atom it is made of. The weights are rounded, so hydrogen is 1, carbon is 12, oxygen 16, sodium 23. For example, the weight of acetic acid is found by adding 4 hydrogen atoms, 2 carbon atoms, and 2 oxygen atoms for a total weight of 60. For the sodium bicarbonate, we added 1 hydrogen atom, 1 sodium atom, 1 carbon atom, and 3 oxygen atoms for a total of 84. In this way, we can calculate the weight of sodium acetate, which is 82, the weight of carbon dioxide, which is 44, and water, which is 18. In our experiments, we will not use 84 grams of baking soda. We will do everything 10 times less. The vinegar comes in a bottle mixed with water and is only 5% acid. Let's figure out how much vinegar to add. 5% acidity means there are 5 grams of acetic acid in 100 grams of vinegar. For 1 gram of acetic acid, we need 20 grams of vinegar. For 6 grams of acetic acid, we need 120 grams of vinegar. We need 120 grams of vinegar to have 6 grams of acetic acid.
So the weight of sodium bicarbonate is 84. But we're going to do it 10 times less, so it's 8.4. Want to start up. So, but it can't measure 8.4. Be smarter. So we're just going to do 8 because this isn't as smart. This is still 0.
Ah! It moved. By nothing. 1 gram.
Alright, this is gonna take a while.
Maybe 8 years tops.
Hopefully. I mean, it could take more. Oh, 3 grams. Okay, it could take less.
5.
4,
6. 7.
wait. I'm just gonna do a little because I don't know. Okay, I should.
8!
Yes, 8. We got 8. Yeah.
So we need to put 6 grams of acid. So since this is 5% acidity, then we have to put 120 grams. So let's do it. Oh, 60. Perfect.
Wow, that's actually really good. So I'm gonna pour this water in this baking soda to make it a liquid. I think a little more should do. All right, time to mix.
It's kind of foggy.
It is very foggy. It looks like milk, but it's not.
Can I drink it?
No, it's not good for you.
Aww.
Actually, do a backtrack. I don't think it's bad for you.
Okay, so you can put all the water.
What do you mean?
Okay.
Whee.
Okay, and then the cabbage juice too.
Cabbage juice.
Also, let's
Our
put,
ultimate hero, cabbage juice.
yeah, let's put 2 of these in here.
Cabbage juice. Cabbage juice. Oh,
Okay.
Oh yeah.
Oh my gosh.
I think this is like a dye.
This
in
is
my
a bit.
opinion.
It might be a dye.
Hey, remember that time? Remember last video? So I'll be putting 2 quarters of tablespoons in some vinegar. Not in this bottle so we don't ruin it, but in this cup.
Use the straw to stir. I cleaned it.
Blood. Oh, that looks cool.
That actually does.
Okay.
So right now I'm mixing this, and now I need to pour it really quickly. That's a nice color of blue.
Yeah. So I need to pour this slowly so we can measure this. Whoa!
Pour more, pour more, pour more. We have a whole glass of it. Well, that's it. Now, watch this be satisfied.
Oh.
Okay.
So it's purple, which means it's not an acid or a base, which means it's neutral.
Alright.
So this bottle is kind of stuck in, and I'm gonna be drawing, and I'm gonna be drilling this.
What a real hole looks
Okay,
like.
yep. Time to go murdering. Ah.
Hi, I'm gonna be putting a little bit of water in here, then 1 or 2 of these in here, mix it, 2. Then we're gonna pour half into here, maybe a little too much in that one.
Alright, even it out.
No.
Mary, you don't need to get anything.
I'll make a sign. Okay.
So I will be pouring this baking soda, and then he will put on the cap, and then
I'm gonna hold it so it bubbles.
yeah.
Mary, run! Mary, run! Run!
Whoa, so
Oh
cool.
my god, zoom in.
Oh, I can feel it. I can feel it.
Go.
Nice. That's cool.
Even more bubbly.
Yeah, and it's now pink, which means it's an acid.
So, as you can see, this is more pink than this one. That means it's an acid. So, we bubbled gas through this tube into here, and that turned it into an acid.
So I have some baking soda here, and I will be putting it in this
Not a lot.
one at a time.
A little more,
Oh, it's inflating already.
Merritt, pour some more.
Yeah, pour some more.
Right, a little more.
It's already
Merritt.
inflating. It's kind of thick.
Not gonna lie.
Oh, no, no.
Hey, can we just pour the
No,
rest?
stay down, stay down.
Pour
No,
the rest.
no, stop. We need to-
Michael, stop.
Oh, shoot.
Oh, it's getting really big. Okay.
There's no foam, so that's good.
Oh, no. Too much, too much.
Okay, it's okay.
It's good. Oh my god, I can feel it getting bigger.
Wait. I can also feel it.
Alright. Oh, too much.
Oh, too much. Yeah.
Yeah.
Oh, wait, no, not too much.
Not too much. Good. Good. So good.
I try to put all.
Or just put everything else in there.
No, too high.
No foam.
You told me to put all. It's your fault if it overflows.
Alright, put
There's
it.
still more.
Put it in, Merritt. Wait, Merritt, if it overflows, it says foam, so just put it all in.
Oh god,
Oh, no.
Oh,
Okay, we're
my
safe,
God.
we're safe.
Oh my god.
Oh god. I'm
No,
gonna die.
No, it's so intense.
This is all filled with carbon dioxide.
Then bring that one over so we can.
Now we're gonna inflate a balloon with air. Merritt, go faster. My hand's getting tired. It's been 3 seconds. Alright, so this is carbon dioxide in a balloon. This is air in a balloon. So which one gets to the ground first? Carbon dioxide. Carbon dioxide, like most things, gets to the ground first because it's heavier. So I'm measuring the temperature of this balloon with air in it. Alright, 24. Now this one with carbon dioxide in it. Alright, this is also 24.
So now we're gonna measure CO2. Alright, it looks like it's 21 point something degrees Celsius. Now let's measure the air balloon. 1.8 degrees, no, 20 degrees.
We did an experiment to see which balloon is hot, air or CO2. CO2 was hotter because CO2 is a greenhouse gas. So CO2 is a greenhouse gas, meaning it traps heat. So whatever it traps gets hotter. Cool. First, I need to fill this with water. Before we had music. Now this is a apple.
And this is pickling lime or calcium hydroxide. Oh wow, the lights turned off. How did the lights turn off?
Hey,
Okay, Mira, just please fill it in so we can do stuff.
And then I pour that in.
It smells like cookies.
All right, now we stir. Let me just do this.
Whee! Oh, Michael.
Michael, if you spill it, that's your fault. Oh wow, it's white now.
So we take this pickling lime, mix it with water in this, and put it in a shot glass.
And now I'm gonna put this in the to see if it's an acid or a base.
Called
base.
it. I called it.
This is the chemical reaction between pickling lime or calcium hydroxide and carbon dioxide that results in calcium carbonate and water. Calcium carbonate is white and makes the solution look milky.
So now I'm gonna put some of this in there.
You mean air?
It just made a huge bubble.
All it did was make a giant bubble.
That's a big bubble. Oh, and let's do this. So I'm gonna scoop this.
It's the most stressful job in the world.
Then put it in here. Put it on.
No!
It's bubbling. It's turning white. People, it's turning white.
We're blowing into the straw, and the straw goes into here.
Oh my gosh! It's turning white. This is action packed. Well, now it turned white. This is actually pretty cool.
It turned white because I was breathing out carbon dioxide.
Okay, you got it. You got it.
Can't. Stupid match.
Vlad, you're supposed to hold this.
Okay, I'm
Oh my gosh, guys, we need it.
I'm gonna pour this acid into here. Oh, it's so heavy with something. More.
That was oddly satisfying.
More action.
I'm trying to get this done so I can see the action.
Action is not gonna happen.
Aw.
Action is dead.
Oh, wait, there's still more in here.
Oh, come
So
on.
remember when we blew in the fire? We were putting CO2 on the fire, but then it blew out because fires need oxygen to survive. Previously, we did an experiment finding out that CO2, aka carbon dioxide, is heavier than air, meaning it's like putting a blanket on the fire.
This parrot, it's desperate for its mother, but you know what it's more desperate for? Science! So dude, now